completed the first portion of this chapter, which is the rate law expression and some questions based on the rate law expression. Okay. Now, in this
Yeah.
class, we are going to start the new thing, which is the order of the reaction, like first order, second order, third order, so nth order reaction. So we are going to discuss about the order of the reaction, half lifetime, and etc. etc. So let's start from the. I think from where we are at the. I think there are some questions that are left. I think so. Have we completed? So there are some questions that I have to give you for the practice. So, okay. Okay, so I'm going to give you some questions, which is based on from the last class. Okay, so before that, I have a question for you. The test that you have given, I have checked the test. Okay, so I want to ask you how much time that which is given to you, how much time it is given to you to solve the test, like 1 hour, 2 hour, how much?
Only 1 hour.
1 hour. Okay. So for our 1 hour, I think the test is very lengthy if it is of one
Yeah.
hour. है ना? Correct.
Yeah.
Yeah,
Yeah.
because the questions are
I think.
all questions are numerical questions. Some of the questions that are I think one question or two questions are theoretical, and other questions are a good questions and having
Yes.
it'll take some time to complete. So it's not the fault from my side because I have given the like key I have to give you 15 questions. So I have given you 15 questions. I am not aware of the how much time that you have. Okay, so if
Okay.
you score half of the marks, like I have checked and you scored 23 out of 40. So that's very good marks if it is a 1 hour test, because half of the paper is actually left, है ना? Because most of the paper I think which is unattempted 50% of the paper. So
Yeah.
23 marks is very very good. Okay, if the paper is of 1 hour. Okay, so just don't
Okay.
focus on the marks that you'll get from the 40, but the rest of the thing is good. Fine.
Fine.
The one thing that I want to point out is that your presentation is not good. You have to work on your presentation. Like if you are solving a paper, so then you have to present
Given.
properly, like what is given
Given.
question and what
Yeah.
you have to find, what is the formula that are you using, and everything is messed up in your solution. So you have to be very much presentable. Your answer should be very presentable so
Yeah.
that the examiner will give you full marks. Okay. So this time I'll check this paper very leniently. So that's why I'll give you the full marks on the basis of the time and all.
Okay.
Okay, so you have to be consider all these things. Understood? So,
Understood.
okay, so I'll give you one question, which is this. Uh, these are the questions which is based on previous classes. Okay, so just solve the questions. These are the very good questions. Do not worry about ki it's very lengthy and all. Okay. So don't focus on the length of the question, just focus on what is given and what you have to find. Understood? Understood?
Yeah.
Yeah, let's do it. So this is the first question that is there. Thanks. So have you written the given part of the things which is there in the question? Like just write the given part. Do not need to write the complete question. Just write the given part which is given to you.
Yeah.
This It's not a very difficult question. It's a very simple, easy question. Just the length is very large because the details are given in the question, which you can ignore as well. So I'll help you to simplify this question. So basically, what is given to you is that it is basically the decomposition of N2O5. So it's very simple. The reaction is very simple, I think so, because decomposition is there. Decomposition in CCl4. Decomposition in CCl4 at this temperature has been studied by monitoring the concentration of this and this. Okay, so we just need to focus on the equation. So just write the equation. So see how I'm representing the solution to you. So first of all, you have to write the equation which is given to you in the question. So this is the equation, gives you 4NO2 gas plus O2 gas. Okay. So this is the equation which is given in the question, and it is the balanced equation, I think. So yeah, it is the balanced equation which is given. Yes. So the equation is already balanced, so we do not need to worry about the balancing wala part. Now, what is given to me is that the decomposition of N2O5 in CCl4 at itna temperature has been studied monitoring the concentration of N2O5 in the solution. Initially, the concentration of this is this, and after this much time. Okay, so initial concentration, initial concentration is your 2.33 mole per liter. So it's very simple. Initial concentration is given to you, and what is given is ki 184 minutes is given to you, that in time 184 minutes its concentration will be reduced to this much. The final concentration would be of N2O5. The final concentration would be your 2.08. And how much time it will take to get from here to here? So this much time is given. So this is the
Mm.
reaction, and calculate. What is to calculate? So to find now, right? This is the given part. This is given. Okay, so this is how you have to represent. Now to find, what do you need to find? You have to find the average rate of the reaction in terms of hours, minutes, seconds. So you have to convert into the different units. First of all, you have to solve in the SI unit, which is basically you are solving from last class, like the questions that I have given you from in the last class. Same way you have to solve it, and just you need to convert into different units. The procedure is same. So what you have to find? You have to find the average rate of a reaction. So basically rate of a reaction is what? I have to solve the rate of reaction based on the things which is given to me. So N2O5 divided by delta T divided by the stoichiometry which is associated with it, which is 2. So this is the formula for the rate of a reaction. Just solve it for seconds. Let's say for seconds. For seconds, my answer would be your change in concentration would be a minus of 0.8 minus. You'll get your, this one would be minus 2.33 divided by delta T. It would be 184 minutes. So I have to, so first I'll calculate in minutes. So because it is given in minutes, so I'll just calculate in minutes. So n minutes. So I just need to put 184 as it is, because minutes I have to solve it, and divided by 2. So this is the way you have to solve. Now the answer you have to calculate by your own self. This is the calculation all about. And in seconds, again, what you need to do? The same thing copied out, divided by, just what you need to do with this is just to divide this with what? 184 multiplied by 60. So you'll get in seconds. Your answer would be in
16.
seconds. R would mean seconds. Just divide by 60. Fine. Now, for hours, what you need to do? For hours, you have to convert this minutes into hour. How are you going to convert this minute into hour? Just divide this by 60. You'll get your hour. Okay, if you divide 184 by
Okay.
60, you'll get your hour into hour. Okay, so this is basically the procedure.
Okay.
Fine. Solve it and then tell
Uh,
me. Solve it. Oh, okay, leave it, because this is the calculation part. You have to do your by your own self. Okay, so do it after the class.
okay.
So what we need to do is divide this by 60. Okay, so I think you understood the concept. What is it?
Yeah.
Understood or not?
Which, what, was it the last topic?
There was a,
Is it based on the last question we did, like the procedure?
it is based on what?
Yeah, what is it? The
Like
steps.
what do you want to ask? What
Like
you are
which
asking?
concept is this? And
This is from which concept? You're asking me this is from which concept? Yeah?
yeah, yeah.
Okay, okay. So this is from this, from the first class that we have discussed in this. This is the concept that we have discussed in the first class of this chapter, which is your.
Okay.
So this is from this. Okay, we are doing the same thing. If you see
Yeah,
here,
okay, okay.
okay. Now
Okay.
I'll give you the question. I'll give you the question. Basically, in this class, we are just discussing the questions. So this is again another question. Solve it. Another question. Solve it. Just do not complete your calculations. Just end up getting the last, simplified form. Like do not solve into decimal and thing. Just get the expression and tell me you'll get that. You just get it. Okay. Do not worry about the calculation. You can do the calculations in your home as well, just to save the time. This is the question. First, write the given part very quickly so that I'll change the. Done.
Is it 0.01 by 25?
0 point.
01 by 25.
Just 1 second. I'll check it.
And
So
for
you
seconds by
are telling me the answer would be 0 point. How much?
01 by 25.
Okay. Okay, let's solve. Let's I'll, so basically again reactant to product. So the given part is my reaction is from reactant to product. The concentration of a reactant changes from this to this. This is the change in the concentration. So basically the change in the concentration, the reactant. So basically the initial concentration would be my 0.03 and the final concentration would be my 0.02. And basically how much time it will take to complete, the time it will take to complete is 25 minutes. Fine. Now calculate the average rate of a reaction. Average rate of a reaction. So in order to calculate to find average rate of a reactant. Average rate of a reactant. So in order to find the average rate of a reaction, what you need to do is that just write like this. This is the rate of a reaction. Fine. So calculate the average rate of a reaction using the unit of time both in minutes and seconds. So again, the same question. This is the same question which is based on the previous question. Okay. So again, the same thing that you need to do. Just write the minus of 0.03 minus 0.02 divided by a time which is 25. So you'll get your answer in minutes. So if you do the same thing, minus 0.03, 0.03, 0.03 minus 0.02 divided by 25 multiplied by how much? With
60.
60 seconds. So you'll get your answer in seconds. So calculation you have to do by your own self. Now let's move on to the next question. Solve it. This is a very simple question. Very, very simple question.
Yeah. First is 1/2. The answer is 1/2.
What?
1/2 is the answer in both.
1/2 of what? First part or second part?
Both. First part and second.
Are you telling me the rate of a reaction is
Order of
uh,
the reaction.
part A is 1/2? Is it?
Order of the reaction.
Second order reaction?
Calculate the order of the reaction.
So is it second or half?
Wait. Oh yeah,
Just
second.
twice and tell me the
Second,
answer.
second, second, second.
Huh?
The first one is second.
Okay, yeah. So solve it for the second. You're correct. Second is this right answer?
What is the, when you zoom in, I can't, it's not visible.
What?
This question, can you zoom in? I cannot see that.
Okay, okay. Just one second, one second.
It's 3/2.
Is it visible now? 3/2 minus 1.
Okay. It's 1/2, the second.
Okay, fine. So, okay, just one second. So let's solve. Let's solve. So see, the question is to
Hmm.
get the order of a reaction. So for the order of a reaction, very simple question. So you see, this one is alpha, this one is beta. An order of reaction is basically addition of the power of the concentrations which is there. So alpha plus beta, your answer would be this. So the answer would be half plus 3/2 you'll get 2. Simple. And if you see here, again, same thing, alpha plus beta, you'll get 3/2 minus 1, you'll get your answer would be as half. Understood? So this is second
Yeah.
order reaction, this is half the order reaction. Now solve this question. This one, solve it. You have to tell me from which order this concentration, this constant is basically from. This constant is it of first order, is it of second order, is it
Okay.
of fourth order? You have to tell me. Just use the formula of the, orders of nth order of reaction, which I have derived in the last class for K constant, if you remember.
Is the first one six?
So first one would be
Sixth order.
no, no, not possible.
No, no, no. Okay. Okay.
See,
Wait, wait, wait.
this is molality constant.
Okay, okay.
This is the to see the formula. I think the formula would be uh here.
First one is zero order.
So the formula would be this nth order of reaction you have to find and the derivation that I have done. So if you see
Yeah,
here,
yeah.
so it would be m to the power 1 minus n s minus 1. So just
One
put the
minus
value of n, just get the value of n, tell me. Okay.
yes.
So what you need to do is the formula would be your
First
m
one.
to the power 1 minus n s minus 1. Okay. So if you see here, if you see here, what is written here? Also, liter is also there. See, liter is also there. So basically, it is written that this is this. So it is basically written that key
Zero.
mole per. So it is written key mole per liter. So power, the power would be m power would m minus one equals to what? Equals to basically minus one. So if you want to calculate, so you'll get this is second order reaction. This is you'll get the value of n as two. If
Second one.
you This is second order reaction. If you see here, so the m equals to zero. It means that if you equate this with
Minus
this
one.
formula, if you equate this with this formula, so you'll get n equals to one. So it means that it is
Okay.
first order reaction. Understood? Understood?
Yeah, is it one or minus one? One.
This is first order reaction. M,
Okay.
yeah. If you see here, M is zero. You have to compare with the formula. If you compare with the formula, you will get one minus n equals to zero. So you'll get the value of n equals to one. So it means that n equals to one. No, it implies that it is first. It belongs to first order reaction. Okay.
Okay.
Yeah. So this is the question. The next question would be this. Solve it. This is the formula. Sorry, this is the question. Now to solve.
Okay. One. Mm. Um, is it is it 1/2
What?
is it 1/2 k into
Okay,
2a?
let's see. So it is given that ki A plus B gives you product. Okay, so when the concentration of only A is doubled. Okay, so it is written that basically what is happening here is ki if the concentration of A is basically doubled, then the rate of reaction becomes half. It means that the effect on rate of reaction would be half if it doubles. Okay. Now the next thing is ki when the concentration of both the concentrations are double, means that if both the concentration are doubled, then what will happen with the rate? The rate of a reaction becomes double. It means that the rate
Double.
of a reaction will double. The rate of a reaction also becomes double. Okay. To determine the rate law expression, so you have to determine the rate law expression. So initially, what you need to do is you just write the given part. The given part is that key my reaction is A plus B gives you product. Fine. And basically from rate law expression, what you need to do is key just write the rate law expression, which is R is equals to K concentration of A raised to the power of alpha B raised to the power of beta. You have to find alpha and beta, and then you'll end up getting your answer. Okay. So now you have to
Yeah.
observe here. If concentration of only A is doubled, it means that my what will happen with the rate of reaction? It halves. It becomes half.
Halves.
It means that basically what is happening with A, what is happening with A. So let's take an example. If I'll take the example of if the power of A, let's say the power of A is 1, then the rate should be the rate should be doubled. If the power was 1, then the rate would be doubled. If the power was half, see, if the power was half, if the power is half, then what is the rate? What do you think? What will happen with the rate? If the power is half, then what will happen with this? This will become root 2. So the rate will end up getting root 2 times. Okay, are you getting the chronology? Like if the power is 1, the rate would be doubled. If the concentration is doubled. Okay. So
Mm.
if the power is
Okay.
half and the concentration is doubled, then what will happen with your rate? It becomes root 2 times. So what you
Okay.
have to do is key what power of 2 end up getting what power of 2 basically power, let's say alpha, end up getting you half of the reaction. What power of alpha is
Okay.
required? Okay, this is the question.
-1.
What power
-1.
of alpha is to be there so that you get answer as half?
-1.
And if you see here, let's do this like this, uh, to the power -1 r. So if you see here, you'll end up getting half if the power is alpha will equals to -1. Understood?
Yes.
So from
Yeah.
this question that is given to you, just write the expression. Okay, you have to write the expression. So the first given part, will you can write it as if the concentration of 2 is doubled, okay, and concentration of B is remains that the same, you'll end up getting your answer as your half. Okay, and from the second part, which is given to you, if the concentration will becomes doubled if my both the concentrations will be doubled. Okay. So now what you need to do is you have to eliminate first initially one thing. So if you want to do this is the first, this is the second, just divide 1 with 2. If you divide 1 with 2, this 2 alpha and 2 alpha will cancel out. K and K will gonna cancel out. R and R gonna cancel out. And you'll end up with this. Your 1 upon 4 is equals to beta upon 2 beta raised to the power of beta. Basically not beta, B, basically B raised to the power of beta, basically B. So B and B gonna cancel out. We'll end up getting 1 upon 4 equals to 1 upon 2 raised to the power of beta. Okay. So
Okay.
it's very simple now. So what power of b is to be there so that the answer would be half. So the b equals to 2.
2.
Understood? If b
Understood.
having a value of 2, he'll end up getting your answer as 1.4. So you have solved your question. The final rate like expression would be r equals to k, a raised to the power of -1, b raised to the power of 2. Understood?
Yeah, understood.
Okay. Now, next question. Solve it.
Is the final answer an expression?
What?
Is the final answer an expression, or do we have to find beta?
Final expression. You have to tell me the expression, I think.
Uh, that r is equal to k into x raised to 1 by 3 and
Okay,
y raised to 5 by 3.
you have to match your answer with me, okay? I'm just solving it.
Okay.
So
Okay.
see what is given to me is that key the conversion of molecules X to Y follows second order kinematics. It means that it is a second order reaction. So basically X is converting into Y, and the order of reaction is your 2, second order reaction it is. So the concentration of X is increased to 3 times. How will it affects the rate of a reaction of the formation of Y? So basically, if the concentration is increased to 3 times, the 3 times, how will affect the rate of the formation of, okay, see. So you have to just write the you have to write the basically the rate law expression. So the rate law expression is basically r k and x to the power of 2. So this is basically rate law expression. From rate law expression, this is
3.
I'm correct or not? According to the question, r is equals to k x to the power of 2. Why? Because it is a second order reaction, and in the rate law you are basically concerned with the reactant. So you have to be defined, the rate law is basically defined with the reactant. So reactant having a power of 2 is basically what? Is basically the rate law expression. Understood? Or is
Okay.
there any difficulty to understand this concept? Tell
Yeah,
me.
understood. Yeah,
Okay, fine.
understood.
Now what you need to do is that keep
2.
3x, if the concentration is 3x, according to the question that is basically telling to you is that, so what is the, what, and then how much the formation of y is affected. So you have you it is in the question that you have to tell me how my dy upon dt is there. You have to tell me this. You have to tell me this. And what is given to you is that key this one is given to you. Okay, fine. Now I'm just equating this rate expression basically with the if my x is 3 times, then what will happen with my rate? What will happen with my rate? Can you tell me? My rate will becomes if my
Hours.
x is 3 times, then my rate
Yeah.
will equals to how much times? 9 times, 9 hour.
Okay. Yeah.
Correct? So it means that
Correct.
dr upon sorry dx upon dt dx upon dt is basically what is basically my r, है ना? Basically r. And what is happening with this? Ki if I increase the concentration, then my rate would be 9 times. So, so what you need to tell me is that ki what will happen with the rate of formation of y. So rate of formation of y is basically equals to minus of rate of dispersion of x. Is this thing is correct or not?
And what's the explanation?
Huh? Is this thing is correct or not? This is the instantaneous rate law expression. If you want to write this like this, you can write this like this. Both the things are same. It is not
Yeah.
given in
Yeah.
the question.
Yes.
So that's why I'm just writing in different ways. Okay. So it's up to you. If you want to
Mm.
write this like this, you can. If you want to write or want to write like this, you can. Okay. So basically, the rate expression for this would be 9r. So it means that the rate expression for dy upon dt would be 9r. So what will happens with my formation of y? It will becomes how much times? It will becomes 9 times. That's it. Very simple question. Are you getting my point or not?
Yeah.
Huh?
Yes. Yes.
The answer would be 9 times. Very simple question. So, okay,
Okay.
I'll give you another question so that it'll easy to you to understand this concept again. Okay, just 1 second. I think I am having this question. Okay, so this is the answer would be 9 times. Okay, so the answer would be nine
Mm.
times. Solve it. This is the similar question.
Okay.
Done.
No. No. Is it
Hmm?
R is equal to K into A raised to 2?
Hmm?
R is equal to K into A raised to 2.
Okay, let's see. So basically, what is given to me is that key A to the product. Basically, when the concentration of A becomes double and the rate of reaction becomes 4 times, determine the rate, law, and order of reaction. So this is the question. So basically, concentration of A. So first write the your equation, the chemical equation. This is the chemical equation, and the concentration of A is basically doubled, then what is happening with my rate expression will becomes 4 times. Determine the rate law expression. Very simple. This question is very simple. So uh, rate law expression is basically R equals to K A to the power of alpha, and it is given that key my if my A becomes double, then the rate becomes 4 times. It means that the value of A is basically the value of alpha is basically 2. So that's why it is becoming 4 times. Okay. So R equals to K A to the power of 4. Oh, sorry, A to the power of 2. A to the power of 2. So this is what? This is my rate law expression. And what is
Yes.
the order of a reaction? The order of a reaction is second order reaction. Second order reaction.
Yeah.
Simple question. So, matched or not? Your answer is same or
Yes.
different?
The same
Same?
answer. Same.
Correct. Very good. So now another question. Solve it. Done. Done.
8 raised to what is 2?
Hmm.
I don't know what 8 raised to what is 2.
Okay. Let's solve it. See, again, same thing. Reaction would be A to product. Okay. And when the concentration of A becomes 8 times, it means that concentration of A becomes 8 times becomes 8 times. So the concentration of A becomes 8 times the rate of reaction. Okay, becomes only double. Okay, so basically, when the concentration of A becomes 8 times, the rate of the reaction becomes the rate will becomes how much time? It will becomes 2. So determine the rate law expression. Very simple question, yeah. Again, see,
Yeah.
just once again. See, what is happening is that key rate law expression is your like this. Okay, you have to find alpha. Again, if you see here, this is basically is the thing. If you see, if you remove all the things, you'll end up getting to the. You have to just get this one. You have to find the power of alpha. You have
Yeah.
to find the power of alpha. So for that, you have to uh you have to do something in the calculation so that the 8 will becomes in some 2 to the power like this, 2 to the power of 3 to the power alpha, like this. If you see here, okay, so 3 alpha equals to 1, so alpha equals to 1 upon 3. That's it. So rate law expression would be r k a to the power m by 3, and order of reaction would be 1 upon 3. Got it?
Yeah.
You have
Got
to
it.
compare. Fine. Just 1 second. Just 1 second. Okay. Just give me 1 second. Hello, hello, hello. Am I audible? Yeah.
Yes. Listen.
So this is the answer, 1 by third. So got it? Are you getting my point? How you need to
Yeah,
solve
I
it?
understood.
Basically, the
Yeah.
condition is given to you. The condition is basically given to you. You have to compare the powers. So for that, you have to convert the like if the base is different, so you have to convert the base into the power so that into some power, the base some power so that easy to compare. If you are comparing the same bases, then it will very easy to solve the questions. If the bases are different, then you have to do something with the base so that the base will becomes similar to the base which is there in the right hand side. है ना? So some power, base some power. Understood? So now we
Yes.
are moving towards the next topic, which is this. So we have solved plenty of questions, I think, and I think it's sufficient that the question that we have discussed. So now, so let's start the next thing. So basically, let's start with the node. So for a multi-step reaction, the slowest step is the rate or determining step. This thing that I have told you in the last classes, that if you want to write the order of a reaction for a multi-step, or if you want to write a molecularity of a reaction for the multi-step, what you need to do is that you have to find the slowest step, so that because the slowest step is the is responsible for the determining the rate of a reaction. If the rate of a reaction is like 10 hours, so it is basically depends on the basically depends on the reaction which is slowest one. Understood? So
Yeah.
what is written is that the rate law expression of a slowest step according to the law of mass action. So this is the most important point. This is the most important. So in previous classes, I have discussed two laws. First one is your law of mass
Mass
action.
action.
Mass action. And law of mass action tells me that if you want to write a rate, you have to write the rate very simple. Like you have to put the powers of the concentration which is equals to the stoichiometry. For example, if my reaction is like this, AB equals to C, okay, and having alpha beta like this. So if you want to write the rate if you want to write the rate of a reaction, what you according to the rate law of mass action, what you need to do, just you need to you need to put the power as your coefficients with which is related, which is with respect to the concentration which is there. Okay, so R is equals to K, A concentration of A to the power alpha, concentration of B to the power beta, basically like this. And alpha and beta is the coefficients which is there. Understood? Now, Now, so this will happens only and only on that step, which is the slowest step, which is the slowest step. This thing you have to do with the slowest step. Like for example, this is the question. See, this is the first example question. So my reaction would be 2NO 2 plus F2 will gives you 2NO2F. Understood? So this is the reaction if you see here. And if you observe very carefully that this is the multi-step reaction. If the multi-step reaction is there, that means there are some steps which is associated with this reaction so that you'll end up getting this main reaction. Okay. So the first step which is there in the question is that NO2 reacts with F2 first to get the NO2F plus F. So this is the first step and this is the RDS. RDS means the step which is the slowest step which is responsible for determining a rate of any reaction of the reaction which is given to you, and this step which belongs to this reaction. So this is the RTS. So what you need to do, the main thing that you have to do with the RTS is that you have to apply the law of mass action here in order to get the rate of particularly this step. Okay, so we are getting the rate of particularly this step by applying the law of mass action like this. NO2 to the power of what? To the power, you have to balance the reaction. So I think the
Mm.
reaction is NO2 is there. So the reaction is balanced. We do not need to worry about anything. So the reaction, according to the law of mass action, this is the rate of a reaction, rate of this step. Understood or not?
Yeah.
Okay, now let's move on to the next step. So the next step would be my NO2 plus F will gives you NO2F. So this is the second step. This is the second step. So what you need to
Second
do?
step.
You have to write the now in the second step, you have to write the law of mass, law of rate law expression. You have to write the rate law expression. So the rate law expression is like this: NO2 to the power alpha F to the power beta. Understood? So this is the rate law expression here, and this is what? This is the law of active mass. So you have applied both the laws in different steps, and the steps which is responsible for the determining a rate, you have to apply the law of mass action, and the other step you have to write the uh, rate of expression. Understood or not? At this point, everything is
Understood.
clear. Now, my
Yes.
motive is to find what is the rate law expression for this reaction. My motive is to find the rate law expression of this one. Understood? So for that, I have to what I have to do, I have to write the rate law expression like this. So if I want to write the rate law expression, so the rate law expression of this would be like this. See here, to the power alpha and f to the power beta. So this is the rate law expression. My question is that you have to find the values of alpha and beta here. You have to find the value of alpha and beta. And for that it is given that there are two
Mm.
steps which is responsible for the main reaction. So in the first step you have to apply the law of mass action. In the second step you have to apply the rate law expression. And what
Yes.
you need to do is that you need to change the rate law expression of the second step into the rate law expression of the thing which is required to me with the help of this one. So what you need to do is that you have to replace this f. You have to replace this f with your f2. You have to replace this f with your f2 because NO2 is which is there. I need NO2. NO2 I need because it is there in my main rate law expression. What I need to do is that I need to replace this f2. I need to replace this f with the help of this reaction. So how I can do it? So what I need to do is that I can do one thing. I can just do one thing. See, if you see here, basically like this, where it is, so if you see here, like, so if you see here, what I need to do is key, I need to write the value of this f2. I want to get the value of f2 here. Can I get the value of f2? Can I get the value of f2?
Yeah.
Bolo,
Yes.
how? How can I get the f2 value of f2? The question is that how can I get the value of F2? You have to simplify the reaction. Okay, you have
Okay.
to simply, let's say this is the K1, this is the K2, because rate constant is different because these are the two different steps. So the constant would be different. Okay. So
Yes.
what you need to do is this thing we are going to study. This thing we have to study now. Okay. So I think you will get the thing that what we are going to do. So basically, this is the thing that we need to study. The thing that I have to tell you is that we have to apply the rate law. We have to apply the law of mass action on the step, which is the slowest step. Understood? So if you see here, if you see in this example, this is my slowest step. This is my slowest step. So in this slowest
Yes.
step, my rate law expression is applied. So if you see R having K, R equals to K multiply NO2 to the power 1, F2 to the power 1, like this. In this step, which is there, power 1, stoichiometry is 1, stoichiometry is 1. So power 1, power 1. Understood?
Yes.
Now, in the second step, now if you see here, R equals to K N2O to the power 1, NO2 N2O to the power 1. Why it is there? Because in the this is the first step and this is the slowest step. Slowest step, you have to write the power as this document power equals to this documentary which is associated with it. For the
Yeah.
slowest step, only for the slowest step. So the order would be 2. 1 plus 1 would be 2. Now, here again, the slowest step is this. Now, the coefficient would be 1. So, if you see the coefficient is 1, the order is 1. Understood? Key how we need to write the order of the slowest step. Understood or not?
Yeah.
Now,
Yeah.
now the next thing that we need to deal with this one. We have to do some simplifications. We have to do some thing so that we end up getting this answer. Main rate law expression. Understood?
Yeah.
Okay. Now let's move on to the thing that I have to explain you. Just 1 minute. Okay. I'll give you some examples for this. Okay. Okay. So just once again. Yes. So I think this one would be the example that helps you. Okay. Yeah. See. Now let's move on to the next step. This is the question that is there. Okay. This is the question. Just 1 minute. Yeah. Now, just see this one. If you see here, what is given to me, I am having 2O3 which converts into 3O2. This is basically the ozone. Basically, I am having ozone and converting this ozone into O2. Understood?
Yeah.
Okay.
Yes,
So
sir.
in this reaction, there are two steps which is responsible. The step 1 and step 2. Step 1 is O3 is basically equilibrium with O2 plus O, and the step 2 is basically O3 plus O plus O3 is the slowest RDS step, which will give you to O2. So now the first thing I want to apply the law of mass action. Where I have to apply, in step 1 or step 2? This is the step 1 or this is the step 2? Where I have to apply the law of mass action? Tell me.
Step two. Step two.
Step 2. So apply the law of mass action. R is equals to K1 multiply by O to the power 1, O3 to the power of 1.
One.
Is it correct?
Yes.
Is it correct? Correct? Now, see, this is your next. This is the first step which is there. So if you see here in the first step, this is the equilibrium sign which is there. So in your class 11, there is a term which is known as equilibrium constant. What is there? Equilibrium constant.
Constant.
And equilibrium constant is nothing but it is the multiplication of the concentration, of the product divided by the concentration of the reactant raised to the power of their stoichiometry. Okay, what I have explained you is that K equilibrium is basically equals to K equilibrium is your equilibrium constant, which is equals to O2. O2 is basically what? O2 is basically the concentration of the product concentration of the multiplication of the active masses, or I can say that multiplications of the concentrations of the reactants which is there in the product side to the reactant which is there in the your basically reactant, not basically the compounds which is there in the product side, divided by the elements which is element or the compound which is there in the reactant side. Understood or not?
Yeah.
So can you tell me what is equilibrium constant? What is equilibrium constant?
Like they have to maintain the equilibrium.
Hmm?
Like
See
both
what I
sides have to be.
huh,
Okay. Okay.
see what I am telling you is that basically it is just one second. Uh, okay, just one second. Huh, see, basically it is nothing but it is the multiplication. See, it is the multiplication of the compounds which is there in the product side. See, this is the product O2 and O. This is the multiplications of the concentration of the product raised to the power of their stoichiometry 1 and 1 divided by the concentration which divided by the concentration which is there in the reactant side to the power of the stoichiometry. That's it. Understood or not?
Yeah, understood.
Now, the next step is that you have to write the rate law expression for the main step. So the rate law expression for the main step would be R is equals to K multiplied by O3 to the power of alpha. That's it. This is what? This is my rate law
Uh,
expression.
rate law expression. Yeah.
Correct? So
Yes.
you have to do simplifications in this one. You have to do what? You have to do simplifications
Simplification.
in this law of active mass with the help of this in order to get this. Are you getting my point? You have to do simplifications in your law of active mass in with the help
Yeah.
of K equilibrium in order to get this expression. Okay, so I am going to do
Yeah.
this. See what is there. O3 is there in the reactant side. O3 is there in the main rate law expression. So you have to get O3. So how I can get O3? Can you tell me how I can get O3?
Um.
What thing that I need to do is that I can replace this O. So in order to replace this O, what I need to do is just write like this. So O is equals to K equilibrium, K equilibrium multiply by O3 divided by O2. So this will you'll get from here. Are you getting my
Yeah.
point?
Yeah. Understood.
I'm trying to say is concentration of O. I have to replace this concentration of O. Why? Because in my main rate law expression, there is no term which is there, which is of only
Of.
O. Okay. So I have to replace this O. So for
Mm,
that, I have to do some simplifications in the K equilibrium. Okay. So I have done the simplifications. Then I need to put the value of this O into this expression. Okay. So I'm going to
yeah.
put the values. See, R is equals to K1 multiplied by K equilibrium O3 divided by O2 multiplied by O3, which is there in this one. Are you getting my point?
Yeah.
Bolo,
Yeah. Yes. Yes. I understood.
correct? Yes,
Yes.
yes.
It's correct.
Now, now, okay, so you have to write the now you can easily write K1 multiplied by K equilibrium equals to O3 to the power of 2, O2 to the power of minus 1. See, this is your rate law expression. And if you simplify, you can write these two are the constant. You can replace these two as a single constant because these two are constant. So you can write it as K. So O3 to the power of 2, O2 to the power of minus 1. And this is the exception question. This is the exception question. So mark this question as exception. This is the exception question. Why? Because I want the expression like this, but I'll get the expression like this. Because I have told you, I have explained you that key in my rate law expression, there is no concentration which is associated with the product. There is no term of concentration is there which is associated with the product. But if you see in my final answer, the concentration of product is also there. which is O to the
Yeah.
power of minus 1. It means that my rate law expression is also depends on the concentration of my O2. Why?
O2.
Why? The answer is that because this your this reaction is basically in the equilibrium. So if any reaction is there in the equilibrium, it means that there is some part of the product is also there for the reaction, for the reactant, for the reactant side. So basically, if any reaction is there in the equilibrium, it means that both the reactant and the product is existing simultaneously. है ना? Simultaneous existence is there. So that's why in my final rate law expression, there is a term which is there of the product side. So this is the only question. This is the one of the only question which is there. Okay, except other questions, there are no terms which is there in the product side. Let's take another example of this same question because this is a very important topic and
Okay.
that we have to deal with. Okay, so the another question would be I'm giving you the question. Okay, so the question is, and this is the last question for the class. I think you are so much tired because there are lots of things that we have discussed in this class. So that's why. Okay, so the question
Okay.
is this. The question is this. See, okay. So question is this. I'm solving this question for you. You have to you have to follow me. Okay.
Okay.
Just just last question. Okay. Last question for the class. See, you have to you have to analyze very carefully. You have to observe me very carefully that how I am
Okay.
doing things. So the first thing is that what I'll do is key what I need to find. I need to find rate law expression. I have to find the rate law expression. And for the rate law expression, the reaction would be A2. See, A2 plus B2, you'll end up getting 2AB. Okay. A2 plus B2, you'll end up getting 2AB. So if I want to write the rate law expression is like this. A2 to the power of alpha, B2 to the power of beta. And you have to find the value of alpha and beta. For that, there are some steps which is there. So if you see that this is the slowest step, just go and find the slowest step. The first thing is that you have to find the slowest step. So the first thing is to uh to find to get to just firstly deal with. So I'm writing the process also. First, deal with slowest step. Slowest step. So the slowest step is this. This is the RDS. So A2 plus B, sorry, not A2, A just, it is just A. So A plus B2, A plus B2 gives you basically RDS, gives you AB plus A. And I have to write according to law of mass action, my rate would be equals to my rate of square step would be equals to a k multiplied by a to the power of 1 b2 to the power of no see I have to simplify. I have to first do your stoichiometry. I have to first balance the equation. The equation is not balanced. 1 and 1 a is there. Only a if you see here at the LHS side 2a is there. So I have to multiply here with 2 and here with 2 like this. Okay, and 2b are there. It means that I have to multiply this with half. So that 1b is there, 1b is there. 2a is there, 2a is there. Understood? So I think the reaction is balanced. Yeah? The reaction is balanced or not? Is the reaction is balanced? 2a and 2a is there. No, the reaction is not balanced, I think so. Why? Uh, Now the reaction is balanced. Is the reaction is balanced? 2a is there, 1b is there. Bolo fast, fast.
Oh yeah. Yes. Yes. Yes.
Is the reaction
Yeah.
is
Yeah.
balanced?
Now it's balanced.
Yeah. So the reaction is balanced. So now I need to write the law of mass action. So k1 multiplied by a to the power of 2, b2 to the power of half. Correct? Correct, correct, correct.
Yes.
Now, just the next step. Next step is to deal with the equilibrium. Go and find k equilibrium. Find k equilibrium. And for the k equilibrium, I have to go to the reaction to the step where the equilibrium sign is there. So if you see, the equilibrium sign is there in this first step. So if you write k equilibrium, so the k equilibrium is basically concentration of A divided by concentration of A2. Correct?
Yes.
Now, the question is ki this is the rate law expression that I need to solve, that I need to get here. I have to end up getting the rate law expression like this. So if you see here in this law of mass action, what is the thing that I do not need? A2 is here. Is there any A2 which is there in my law of mass action? Is there any A2?
No.
Huh? No. So I want A2 here and I want to replace this A here. So how can I replace the A? I want to replace the A. So for this what I need to do is I just want to write A. So if you see A2 square is equals to K equilibrium into A2, and A having K equilibrium power half, A2 power half. Is it correct? Is it correct?
A2.
What I do is that I just do some simplifications in order to get the value of
Yeah.
A. Are you getting my point or
Yeah.
not?
Yeah. Understood. I understood.
Yeah. So just you need to put the value of A here. That's it. So after putting the value of A here, K1 into K equilibrium to the power of half. Now A2 to the power of half, B2 to the power of half, B2 to the power of half. So the final answer would be R equals to K. This K1 multiplied by K equilibrium to the power half equals to K. Why? Because this is the constant. If you multiply the constant, you'll end up getting constant. So I just replace these two with single constant. That's it. So
Yes. Yeah.
constant A2 to the power of half, B2 to the power of half. Now you'll get your answer. So what is the order of a reaction? So the order of reaction is what? Order of reaction is 1. Half plus half would
One.
be
Yes. Yes. It's one.
1. So this is the rate, this is the order of reaction. So this is the first order reaction. Understood how I have solved the multi-step reaction, how I'll able to get the rate law expression of the multi-step reaction. Bolo.
Yes. Yeah.
So this is all about this class, and we have solved many lots of questions. There are, I think, how much questions we have discussed. Things. So it's around, like, we have start from here. So 24, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, 12 questions are discussed in this class, and I think it's enough. It's enough for this topic, you know, and you'll get similar questions in your exam. Okay, so you have to just
Okay.
resolve the questions like this. Okay, again solve the class
Okay.
illustration. That's it. It's enough. Okay, any doubt?
Okay. Constant raised to 1/2 will still become a constant.
Okay, so you are basically asking me about the constant to the power of half multiplied by k1, it'll end up getting k. How this one is done, है ना?
Yeah.
This thing na k1 multiplied by k equilibrium to the power half.
Yeah. Yeah.
See, if I want to write a rate law expression, there is a term which is k, which is there. Fine. And k is a
Fine.
constant. K can be any number. K can be any number, any constant, like 1, 2, 3, 4, 5, 6, anyone, any number which is there. Understood? K will be any number. So if k is any
Yeah.
number, it means that if two constant, and I know that k will be there is some factors which is associated with k. Like for example, if my k, let's take an example, like my k is 4. So how many factors of k is there? 1 multiplied by 4. and 2 multiply by 2. And these are the factors which is associated with 4. So basically,
Yeah.
my K1 and K2 are some constants. After multiplying these two constants, you'll end up getting K. So you do not need to worry about
Yeah.
the constants. Constants is the thing that will, automatically adjust itself. Okay, you have to just worry about
Okay.
the powers of the concentrations. You do not need to worry about the constant terms, because they'll, automatically arrange yourself. Understood? Because these are constant.
Understood.
The values are not going to be changed, but the values of the concentrations can be changed, because there are some variables that which is also associated with it now. So that's why it is happening. Understood?